Hey everyone, and welcome to this explainer. Today, we're cracking open a high-level intelligence dossier to analyze the really fascinating, highly classified realm of orbital proximity operations. We're essentially looking at a domain that is transforming right before our very eyes. It's shifting from this peaceful sanctuary into a heavily congested, highly contested environment where the satellites that basically run our modern world are increasingly at risk.
So, let's dive right into this rather provocative question. What actually happens when a multi-billion-dollar satellite is stalked in the dark? Because the reality is, way high up above us, completely out of sight of the naked eye, these massive assets are being trailed, observed, and sometimes even physically approached by highly maneuverable, largely classified spacecraft. When a satellite suddenly goes silent, or when an unfamiliar object drifts just a little too close, the stakes are literally astronomical. What exactly is happening up there? And really, who is watching the watchers?
To unpack all of this complex info impartially, our briefing today is going to cover 5 quick areas. First, the rise of space sentinels. Second, orbital mechanics. Third, a look at the global programs. Fourth, proximity incidents. And finally, the legal gray zone.
All right, starting with part 1, the rise of space sentinels, and this completely new orbital reality.
To really understand this new reality, we have to categorize the suspects up in orbit, right? First up is the inspector satellite. You can basically think of this as a scout. Using what are called non-cooperative maneuvers, which is just a fancy way of saying they approach without asking permission, these platforms observe foreign spacecraft or try to diagnose friendly hardware issues from a distance. They're loaded up with high-resolution cameras, infrared sensors, and LiDAR. They're the eyes and ears of the orbital environment.
Now contrast that with what's called a bodyguard satellite. This is essentially your tactical wingman. Instead of just passive surveillance, it's actually designed to shadow a high-value asset and actively shield it. These platforms can identify approaching interceptors and, if necessary, escalate force. We're talking about utilizing everything from electronic countermeasures to physical interception using robotic arms. And then, finally, we have the Co-orbital ASAT, which stands for Anti-Satellite Weapon. And guys, this is where the line gets really blurry. A co-orbital ASAT is an offensive system that exploits the exact same proximity maneuvers as an inspector or a bodyguard, but its intent is to disrupt, degrade, or straight-up destroy a target. That could mean a physical collision, orbital grappling, or even non-kinetic attacks, like jamming radio frequencies or blinding optical sensors.
And what we're looking at here beautifully illustrates that wider spectrum of counterspace capabilities. The threat isn't just floating in orbit. Nations are developing a full array of systems. You've got terrestrial, truck-mounted jammers down on Earth that can sever communications, all the way up to directed energy weapons and cyber ops. But it's those co-orbital systems, the ones physically sharing the vacuum of space with their targets, that present the absolute most complex strategic challenge.
Moving right along to Section 2, orbital mechanics, and the actual physics behind these space sensors.
So how exactly do you maneuver one spacecraft right next to another when they're both screaming along at 17,000 miles per hour? Well, generally you have 2 approach corridors. First is the V-bar, or velocity bar approach, which coasts along the target's path. It's incredibly energy efficient, but big catch here, if your spacecraft loses power, momentum's going to pull it right into the target, risking a fatal collision. On the flip side, you have the R-bar approach. This requires continuous engine thrusts to literally climb up toward the target. It burns a ton of fuel, but it's safe. If the engines fail, gravity just naturally pulls the chasers safely away.
Since all of these operations happen literally in the dark, how do we even see them? Well, open-source analysts identify these secret sentinels using commercial space awareness firms like Exoanalytic Solutions. They use these massive global networks of optical telescopes to track anomalies in the satellite's 2-line elements. Think of a 2-line element as basically a spacecraft's license plate and home address. By monitoring those coordinates, along with radio frequencies, analysts can actually catch these silent maneuvers in action.
Okay, Section 3, Global Programs. Let's do a quick head-to-head comparison.
This table here maps out the major players impartially based purely on open-source intelligence. For the United States, you have the GSAP program operating out near geosynchronous orbit. Officially, it's dedicated to space situational awareness and anomaly resolution through frequent close proximity operations. Then, Russia operates the Lech and Olymp series, which have been observed multiple times shadowing foreign communications satellites for suspected intelligence collection. And China operates the Shenzhen series, which have demonstrated some really complex on-orbit servicing tech, including actually physically grappling dead satellites and moving them around.
Seeing the sheer number of rocket launches fueling this expansion lately really drives home a critical takeaway for us. The physical capabilities required for peaceful commercial servicing, like, say, repairing a broken satellite or cleaning up space debris, are virtually identical to the capabilities of a co-orbital weapon.
And other nations aren't just sitting back watching this play out. They are actively developing their own active defenses. France is actually leading a $6.5 million project to build an autonomous bodyguard satellite that can counteract threats with lasers or robotic arms. India, after experiencing their own close orbital encounter, started a satellite protection project, aiming to test robotic arms in orbit by 2026. Japan is planning to launch tactical agile escort prototypes by 2029. Even Germany is outlining plans for low-circle surveillance space plans. So this whole orbital wingman concept, it's rapidly becoming global industrial policy.
Which brings us to Section 4, Proximity Incidents. Let's look at some documented close calls.
To give you an idea of what this actually looks like in practice, we can look at data from the Center for Strategic and International Studies. They have cataloged numerous highly unusual behaviors over the past few years. We're seeing platforms traverse the entire geobelt, conduct literal corkscrew maneuvers around other satellites, or purposely position themselves to cast shadows directly over the camera lenses of other surveillance satellites. It's pretty wild stuff.
And if you look at this timeline, it reveals a really clear pattern of escalation. In January 2022, open source trackers watched China's SJ-21 go missing during a daylight gap, only to find it later having successfully grappled a dead satellite and dragged it out to a graveyard orbit. Then, in May 2024, Russia placed Cosmos 2576 into an exact coplanar orbit with a U.S. satellite. Fast forward to January 2025, and Russia's Launch 2 came within just 1 single kilometer of an international communications satellite.
All right, finally, Section 5, the legal gray zone and the glaring policy gaps in space.
So with all these close encounters becoming totally commonplace, you might be wondering, why are they permitted at all? Well, it all comes down to the 1967 Outer Space Treaty. It relies heavily on the phrase you see right here, due regard. Nations must act with due regard to the interests of others. Now, that sounds nice in theory, but in practice, it's a legally toothless, completely subjective standard. It totally fails to define what constitutes a hostile act, or even how close is too close.
Here's the crazy part. Because international law establishes literally no recognized keep-out zones, a foreign Sentinel satellite can legally maneuver to within a few hundred meters of a high-value asset, just claiming it's conducting a peaceful tech demo. This creates a terrifying dual-use paradox. A satellite with a robotic arm could be a peaceful mechanic or a deadly weapon. And since the treaty's mechanism for harmful interference has literally never been formally invoked in its nearly 60-year history, intent is incredibly ambiguous and practically impossible to prove until a physical action is actually taken.
This leaves us with a final, really provocative thought to take away from this explainer today. As this orbital arms race accelerates under the guise of ambiguity, and nations rush to deploy bodyguards to protect their assets from so-called inspectors, how will humanity successfully govern a battlefield we can barely even see? Thank you so much for joining me to explore this critical topic. Keep your eyes on the skies, guys, because the real action is happening right above our heads.